Hello everyone, how's it going? So today I'm gonna walk you through the code base of my multi-agent system that I have talked about in my last video. If you haven't watched that video yet, I'll be giving the link to that in the description below. So please go and watch it to at least get the context of it. So without further ado, let's get started. As I've said in my previous video that I have developed this multi-agent system using Strands framework, which is an AWS agentic AI framework, and I have used Swarm design pattern for it. So if you can look at this code base, as you can see, I have imported the Swarm package from strands.multiagent and some built-in tools of Strands. So, so here we are creating our Swarm by initializing our four agents, and these are the some of the parameters that we can use in this design pattern. Like the max handoffs, the max overall handoffs that the agent in the Swarm can do, max iterations execute, no execution time for the Swarm, like how long can the Swarm run without giving a timeout error, and no timeout is how long can a single agent run. We can specify that here, and the repetitive hand of detection window, repetitive hand of minimum unique agents, bit of a reverse engineering here. So we are going to do a bit of a reverse engineering here, so like how I actually went about implementing this. So we will start with each agent. So I've started with defining each agent, like here, architect. The model we are using is Bedrock Cloud 4.5, and the description of each agent and the system prompt. The system prompts are really lengthy, so I'm not gonna go into detail with that, except I want you to know that I have followed the cloud's best prompting principles here. One of the, if you can go on Google and type Cloud 4 prompting strategies, you'll find this official documentation of Cloud, where you can find the best prompting principles or practices. One of the examples of best prompting practices of the cloud Anthropic Cloud is writing instructions in this XML tag format. Like for each section, you can define a sub unique or separate XML tag, and then write your instructions inside those tags. To So it is crucial for us. See, the prompting is what gives the agent strength. So it is crucial for us to implement the best prompting practices suggested by the model provider to actually bring out the LLM strengths. And as we go ahead, there are these other agents: designer, developer, and a tester. And I had registered all of those agents into a swarm, and I've tested it locally. It was working fine locally and all, but I wanted to implement handoff to user. So when each agent executes, it would return a handoff to user for user approval and then proceed to the next agent, like human in the loop. So I searched the Strands documentation to see if there is anything related to human in the loop, and I found out that they have an inbuilt handoff to user tool. So in this current swarm logic, so I implemented that into my swarm, and and in turn, I also found out that the handoff to user tool that Strands provides only supports terminal environments. Like if you go to the Strands documentation and search for handoff to user, you will see the human in the loop handoff to user, that this tool is designed for terminal environments, and for production applications you may have to implement your own custom handoff tool. So obviously I didn't go ahead with this custom handoff to user tool approach. We would have to return the, because there's a UI in the picture, right? We'd have to return each agent's response to the UI and then get the user response back. But there's another catch here. It is that the HTTP request response cycles, it would after, like for example, an architect agent returns its response back to the user, it would lose all its state. When the user replies, the swarm will have no state of what architect agent did. It would have to start all over again, and it would have to start all over again. So I needed a way to preserve that state. So I explored options. What can I do for it? So I explored external state management options. Like after each agent executes, it would the response would be returned to the UI, and simultaneously will be stored in an external DB, like a Cosmos DB or a Dynamo DB. And after user responses back, the previous agent state would be injected back into this form object. So I tried that. That if after one agent, the assumption here would be after an agent executes and gets the user response back, the previous agent state, when the previous agent state is injected back into the swarm, it would resume from the next agent, right? And but it didn't. It gave me an error. It didn't. The architect agent, in my case, after implementation, it worked. Architect agent returned the response, fetched the user response back, but it threw an error there. The error was session persistence is not supported for swarm agents yet. So, like external state management, like we can't inject the external state back into the swarm and expect swarm to continue from where it left off. Specifically in Strands swarm, I think Autogen swarm supports it with the because they have a universal because they have universal functions implemented like load state and save state. But in Strands swarm, it was not implemented yet. I searched the internet and I found out that the state persistence in Swarm in multi-agent design patterns in Strands is a requested feature but not implemented yet. So I'd have to think of some other way. I then decided to remove the handoff to user uh, completely and then just return the final response back to the user, which we'll get back to it. So I decided that I implemented that. I then pushed the code to Lambda and it was working. But it was not so user centric, right? Oh, the user would receive time to time, but the user centric approach would be that the user should receive time to time updates on uh, how far the swarm execution has come to, like what agent is running right now, what is the progress and all. So I explored the streaming options. I have searched the Strands documentation to see if there is anything related to streaming. So I found out this. So here I found this, as you can see in the streaming, there's this async iterator called agent.streamAsync, which would get each agent's events. Like after each agent executes, it would then fetch the events. It would then fetch the events, and then we can just stream those events via some other mechanism. So so this is just the part for extraction of events after each agent executes. So in my code, if we go to this logging handler, here as you can see async for event in swarm.stream async. What will this do is that it will extract these event types: the multi-agent node start, multi-agent handoff, and then multi-agent node stop. That contains this multi-agent node stop contains the agent name and the node result. The node result is nothing but the agent's result, that particular agent result. For example, the architect's agent's response. For example, each agent's response. So here we are extracting these events from the streaming functionality. And also there's this upload to S3 function which extracts these events and uploads it to S3. These are just audit logs, just for reliability and logging purposes. Now the problem here again was that it is just extracting those events from it. How can I stream it back to the UI? See it, you guessed it, it's WebSockets. So I've used the cloud.ai, ChatGPT and all to see if how can I use WebSockets into this how can I use WebSockets from a cloud perspective. I figured that there would be any services in cloud as well. So in AWS, I wanted to know if there is any availability of WebSockets, and I found out that a WebSocket support as well. And I found out that API Gateway has WebSocket support as well, which led me to the implementation of WebSocket Manager.py here, which would create a WebSocket connection between the client and the server. And in the logging handler, we are using this WebSocket Manager to uh, send the events back to the to push those events into the connection. So as you can see here, multi-agent node stop, we are taking the agent names and node result, and then we are calling this log agent result function, in which it is just pushing the agent result back into the WebSocket connection. But if you notice, we are missing something. We haven't implemented that handoff to user tool yet. So for that, I had to create my own, handoff to user tool, which we would find it here in tools.py, yeah, handoff for user approval tool. So this is a custom tool that I have created for each agent and that I have created. But how would we use it? Like, if you watch my previous video, you would know that the API gateway has only 30 seconds timeout limit, and we would have to return something immediately and then asynchronously invoke the worker lambda. So that is exactly why we have this connection handler here. It will a connection handler here. It does that, and if you notice, the API gateway would be connected to connection handler lambda, not to the worker lambda. So connection handler lambda will establish the WebSocket connection between client and the server, and the worker lambda would push the events back to push the events into that connection ID, but it wouldn't be able to receive the user responses back from the client directly. It would have to go through the work connection handler lambda, right? So that's why I've implemented this approval store.py, which basically stores the user requests and responses into a DynamoDB table named swarm approvals, and our worker lambda would be continuously polling the DynamoDB table for the user response. If you can see here in the handoff to user approval tool, it is continuously polling for user response like every 2 seconds. After it receives the user approval response in the DynamoDB table with the same approval ID that the request was sent, then it would fetch that response and then uh, give it to the agent for the agent consideration of what to do next. And all these other tools would be like this. We have this upload session to blob tool, which is used by the tester agent. Like, after the deliverables are generated, it would have to return to you. For returning to UI, it would have to store it externally somewhere. So we are using Azure blob storage. We did an Azure blob storage, and after the deliverables are generated, it would upload the deliverables into an Azure blob storage with a unique session ID. We also have this session manager.py. So the purpose of this is, let's take an example. If the developer agent has to write the deliverables, right, how would it write and where would it store it? So we are creating a temp directory initially, and with a unique session name, temp directory. So like, for each session there would be a separate temp directory, and the agent would write into that temp directory the deliverables into that temp directory, and that temp directory would be uploaded as a whole to the blob storage by the tester. So likewise, we are doing that. And finally, if you didn't understand this connection handler part, then you would have to watch my previous video where I clearly explain why each component is implemented the way they are. And finally, I will talk about the trade-offs or the things you could have done differently. So this, instead of having this worker handler lambda continuously poll the DynamoDB table for the response, we could implement that AWS event bridge, where after receiving the response in the DynamoDB table, it will just automatically trigger the worker lambda, automatically send the response back to the worker lambda, you know, and the worker lambda will do its thing. And there's this other way of using Redis instead of DynamoDB table, which is faster. For better scalability, we'd better go with Redis or any other service. Here is that Redis is costly. DynamoDB table, we will be using it as in a pay as you go model 24/7, but for the Redis it will be charging for 24/7. So that is also one thing to keep in mind. And yeah, that's it. I will give the link to the code base in the description below. Feel free to check it out, and leave a star to the repo if you like it. Yeah, if you have any doubts or any queries, or would like to suggest any better architecture for this implementation, feel free to chat in the comments. Please like, share, subscribe, and I'll see you in a bit.